Welcome friends. In this class, we are going to discuss how we can solve and find the nature of roots of a quadratic equation. It is extended scope of Taylor frame. Please like and subscribe the channel. Friends, we are going to solve a quadratic equation on Taylor frame, and we'll also learn on Taylor frame how it can be defined, how the discriminant of a quadratic equation can be found, what is the formula, and how it is presented on a Taylor frame for finding roots of a quadratic equation. We will also discuss the nature of roots of a quadratic equation and examples for all above topics. Friends, we are going to define a quadratic equation and also going to learn how it can be presented on a Taylor frame. We will extend it to find discriminant and other things. Defining a second degree equation with one variable is called quadratic equation. Symbolically, it is represented as ax squared plus bx plus c is equal to 0. For example, x squared minus 5x plus 6 is equal to 0 is a quadratic equation because it is second degree equation, as x square is the highest degree term. Therefore, and there is also only one variable x, so it is fulfilling all conditions to be a quadratic equation. On Taylor frame, we can easily represent a quadratic equation as I have done just now. Ax raised to power 2, that is ax squared, this is ax raised to power 2 ax squared plus bx plus c is equal to 0. So we can easily represent a quadratic equation on a Taylor frame and do whatever calculations are required to find roots, nature of roots, etc. for it. Example as we are considering is x squared, x raised to power 2x squared minus 5x plus 6 is equal to 0. All the normal symbols can represent a quadratic equation on Taylor frame. Let us see how to find discriminant of a quadratic equation. Discriminant of a quadratic equation is an important part of quadratic equation as it is used to find roots of a quadratic equation and also the nature of roots of a quadratic equation. If quadratic equation is ax squared plus bx plus c is equal to 0, then its discriminant is defined as d is equal to b square minus 4ac. This is also the formula to use the discriminant. For example, discriminant of x square minus 5x plus 6 is equal to 0 can be found as d is minus 5 squared because b is minus 5. So it is minus 5 squared b square minus 4 a is 1, coefficient of x square is 1, c is 6. Thus we get 25 minus 24 or d is equal to 1, that is value of discriminant of x squared minus 5x plus 6 is equal to 0 is 1. On Taylor frame, D is equal to b raised to power 2, that is b squared minus 4ac. So easy to present. So it will be equally easy to solve a quadratic equation on Taylor frame. D is equal to b square minus 4ac, we have already seen. In the equation, x squared, x raised to power 2 minus 5x plus 6 is equal to 0. D is equal to brackets open minus 5 brackets close raised to power 2, that is minus 5 squared minus 4ac. A is 4 minus 4a c. A is 1 into c. C is 6. So it is 4 into 1 into 6. 4ac. This way, discriminant D is equal to 25 minus 24. Discriminant D is equal to 1. Thus, using Taylor frame, we have calculated the discriminant of a quadratic equation. Formula for roots of a quadratic equation. On paper as well as on Taylor frame. On paper, two roots of a quadratic equation are given by the formula x is equal to minus b plus square root of d upon 2a. And the second root is x is equal to minus b minus square root of d upon 2a. There is only one difference. One is plus, one is minus. Very simple. Because we are taking square root of d, and in square root, when we take square root, we give plus minus sign to it. We assign plus and negative sign to it. Therefore, we get one root by adding d, square root of d, and the second by subtracting square root of d. Now let us see how we go ahead on Taylor frame. Look, the formula x is equal to minus b plus square root of d upon 2a. I think you remember very well that when we write a fraction, we write numerator in one row, then leave a blank row and write the denominator after it, below it. Okay, so we have easily represented first root of a quadratic equation. Same way, x is equal to minus b minus square root of d upon 2a. Right? Only difference between the two was one is positive and one is negative. Right? Let us now find roots of a quadratic equation on paper as well as on Taylor frame. In the equation x squared minus 5x plus 6, what we have is a is equal to 1, that is coefficient of x square is 1, b is minus 5, coefficient of x is minus 5, and c, the constant term, is 6. Therefore, applying the formula for discriminant, that is b squared minus 4ac, we get d is equal to minus 5 squared minus 4 into 1 into 6, which is 1. We have already calculated it also. Now x is equal to, using the formula, minus b, that is minus of minus 5, plus square root of d, that is square root of 1 upon 2, which is equal to 5 plus 1 upon 2 and is 3. This way we have calculated on paper the first root of the quadratic equation. Let's move to the Taylor frame. X raised to power 2, that is x squared, minus 5x plus 6 was our equation. Now in this, a is equal to 1, b is equal to minus 5, this is minus, this is 5, so b is equal to minus 5, and c is equal to 6, this is c is equal to 6. So we have written the coefficients of x square, x and the constant term on the Taylor frame. Calculating d is equal to brackets open minus 5 brackets close raised to power 2, that is b squared minus 4 into a, which is 1, into c, which is 6. Calculating it, we get d is equal to 25 minus 24, which is equal to 1. Thus d is equal to 1. Discriminant of the quadratic equation here is 1. Now we know x is equal to minus b. So it is minus brackets open minus 5 brackets close minus b, because it is minus 5, where b is minus 5, minus b, then plus square root of d. Square root of d is square root of 1 divided by 2a. 2 into a was 1. Thus, on calculating, we get x is equal to 5 plus 1 brackets close divided by 2, which is equal to 3. Thus, first root of the quadratic equation is 3. Similarly, second root is minus brackets open minus 5 brackets close minus root of 1. This time it is minus d. Only difference is this, divided by 2a, which is 2. And on solving it, we get 5 minus 1 upon 2, which is 4 upon 2 and 2. On Taylor frame, x is equal to minus brackets minus 5 brackets close minus now square root of 1 divided by 2 into a, 2 into 1. And on calculating, we get x is equal to 5 minus 1 brackets close divided by 2, which is x is equal to 2. So second root of quadratic equation is 2. Using these things, we can find roots of any quadratic equation. Now let us talk about the nature of roots of the quadratic equation. If we know the discriminant of the quadratic equation, we can tell what is the nature of its roots. If d is less than 0, that means if d is negative, no real roots exist. If d is equal to 0, real and equal roots exist, because plus minus root of d will be 0, 0. So both roots will be equal. A quadratic equation can have at the most two roots. At the most two roots means it can have no real roots, it can have both roots equal, or it can have different roots if d is greater than 0. If d is greater than 0, both roots will be real and different. at this level as we first calculate d, and if we find d to be negative, we need not calculate the roots of the equation. In fact, we won't get the roots of the equation because square root of a negative number is not real. Please note that roots of a quadratic equation can also be determined by factorization. We will learn it in some other class when we will discuss linear factors. Thanks for watching.